Today's notes are on perpendicular bisectors. So let's recall the definition of perpendicular. Well, it's when two lines intersect to create a 90-degree angle. So you'll have two lines intersecting and that little right angle mark. So it's created by the intersection of two lines at a 90-degree angle. Definition of bisector. Okay, so a bisector divides a segment into two equal parts. Bi meaning two. All right, so a perpendicular bisector of a triangle is a line, array, or segment that intersects the side of a triangle at a 90-degree angle and at its midpoint. Every triangle has three perpendicular bisectors. Let's take a look at this first one. This is a perpendicular bisector. This could be a line, a ray, or a segment, and it is intersecting at a right angle, and each of these segments is congruent. If it's bisecting, we're cutting it into two equal parts. Here are some examples that are not perpendicular bisectors. You can see that this is not a right angle, and over here on this one, this is not at the midpoint because these segments are not congruent. The perpendicular bisector theorem says if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. If CD is perpendicular to AB, so we've got CD perpendicular to AB, and AD is congruent to DB, then AC is congruent to BC. The converse of the perpendicular bisector theorem states that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So the converse, remember a converse is where we just switch these two statements. So we're starting with the conclusion. If AC is congruent to CB, then CD is perpendicular to AB and AD is congruent to BD. Let's try some examples. All right, so what that says is that these two expressions are going to be equal to each other. So let's write them down. 13x minus 48 is equal to 7x plus 24. If I subtract 7x on both sides, that gives me 6x. And if I add 48 to both sides, that's going to give me, how about 72? If I divide both sides by 6, x is equal to 12. In problem number 2, both of these segments are congruent to each other. So 17x minus 3 is equal to 9x plus 13. Because if these pieces are congruent, then these pieces are going to be congruent as well. All right, let's subtract 9x from both sides. That gives me 8x. And if I add 3 to both sides, that gives me 16. And divide both sides by 8, so x is equal to 2. All right, same situation here. We have two sides that are going to be congruent to each other. And so 7x minus 22 is equal to 4x plus 5. And that again is because this is RT is a perpendicular bisector. So let's subtract the 4x on both sides, add 22 to both sides, and we get 3x is equal to 27, so x is equal to 9. But let's answer the question, what is RS? We're going to plug in 9 for our x, and we get 36 plus 5, which is 41. Question number 4. 2x plus 11 is equal to 14x minus 37. Let's subtract 2x both sides, add 37. All right, so we have 48 is equal to 12x, and so x is equal to 4. If I substitute in For my x, 2 times 4 plus 11, that's 8 plus 11 is 19. And that is actually the measure of EG. 2 more examples. Okay, just a little bit more algebra here. Subtract 3x both sides, that gives me 2x. Add 11 to both sides, and that gives me 28, so x is equal to 14. This time, if I plug it in right here, 5 times 14 minus 11 plus, actually, I need to find that whole distance, so 3 times 14 plus 17. I'm going to put that in my calculator, and that gives me that AD, or AB, sorry about that, is equal to 118. And the last problem, JK. So again, congruent segments. So 6x minus 26 is equal to 3x plus 34. I'm going to subtract 3x and add 26 to both sides. That gives me 3x is equal to 60 and x is equal to 20. It's asking me to find JK, so I'll substitute in the 20 for the x. And that's 120 minus 26, and I believe that is 94. That is your JK.